Welcome to our new video about Newton's second law of motion, concept of a system. We previously did some exercises here, so today we're going to solve exercise 13. It's going to be very easy, and it says the weight of an astronaut plus his spacesuit on the moon is only 250 newtons. How much do they weigh on Earth? What is the mass on the moon? On Earth? So let's try to solve it, and the exercise is on our blackboard waiting for us, and there we have it. And well, first of all, we are going to calculate the weight of the astronaut. No, wait, we already have it here. There. So we already have the weight of the astronaut. What we need to isolate is the mass of the astronaut plus his spacesuit. So the weight of the astronaut is 250 newtons equals to the mass that we don't know times the gravity. Okay, here we don't have the value of the gravity, but you can Google that, and it's very easy to find it. It's actually 1.62 meters per square seconds. As I told you, this data is not provided by the exercise. Nevertheless, you can Google the answer. So there we have it. The only thing that we have to do is isolate the unknown, the mass. So we will have 250 newtons divided by 1.62. meters per square seconds. Now, we have a problem here because the mass is measured in kilograms, and there are no kilograms there. So where are they? Well, let's remember that newtons is equal to kilograms times meters per square seconds. Don't forget that it's very important in order to solve these kind of exercises. Meters per square seconds. So instead of writing newtons there, I'm gonna write kilograms times meters per square seconds. So there I have it, and well, 250 divided by 1.62 is gonna be 154.32 kilograms. Since we cancelled the meters per square seconds from above and from the denominator. So the answer is just kilograms. And that is the mass of the astronaut plus the spacesuit. Now, what is going to be the weight of the astronaut and the spacesuit on Earth? Okay. Well, this time we won't have to isolate the mass. This time our unknown is the weight. So, since we already know the mass of the astronaut plus the spacesuit, we're going to replace here 154.32 kilograms times the value of the gravity on Earth, which is 9.8 meters per square seconds. Finally, I multiply that, and the weight of the astronaut on Earth, it will be 1,512.34 newtons. Since kilograms times meters per square seconds is equal to newtons. Don't forget, the mass on everywhere is going to be the same because the mass is the amount of matter that you have on your bodies. So the mass is going to be the same on the moon and on Earth. But the weight is something different because the weight depends on the gravity, and the gravity is different from one place to another. In this case, from on moon and on Earth. So the weight is going to be very different. As you can see it here, the weight on the moon is 250 newtons and the weight on Earth is 1512.34 newtons, but the mass is going to be the same. Okay, that's all for this video. I hope you could understand it. It's very easy. It's a big piece of cake. And I'll see you in the next video. Don't forget to give me a thumbs up and goodbye.